Hey everyone, welcome back to the channel. Today we are into something really exciting and of course practical. An easy and futuristic way to connect to your MAVLink based drone or even robot anywhere in the world. And when I say anywhere, I mean it. Whether it's on your local network at home or to the other continent or even an explorer robot that you have sent in the middle of ocean or to the North Pole. Just by using a 4G, 5G, 3G, or even satellite-based connections like a Starlink. Now some of you might remember my old 2020 tutorial about MAVLink over Internet using ZeroTier and MAV proxy. While that method still works, I wanted to share a much simpler and more streamlined approach for 2024. This new solution is way more straightforward and easier for beginners. In this tutorial, I'll walk you through three main steps. First step is how to set up MAVLinkAnywhere on your Raspberry Pi or any other Linux-based companion computer for local MAVLink forwarding, such as your local network in your home, in your lab, or even on field with some portable Wi-Fi hotspot. Then I'll walk you through how to install and configure Smart WiFi Manager to keep your connection robust and reliable when you are using Wi-Fi. And the exciting part 3, how to set up remote internet-based MAVLink streaming using NetBird to connect with both your smartphone, laptop, or even several other robots and drones. I'm focusing on NetBird in this tutorial because it's incredibly beginner-friendly, but keep in mind you have other options as well, such as Telescale, ZeroTier, or any other implementation of WireGuard based in VPNs, or even traditional port forwarding from your router if that's what you prefer. So let's dive in and get your drones connected no matter where you are in the world. Okay, let's quickly jump into the MAVLinkAnywhere GitHub repository, where you can find all the helps, instructions, and documentation. Let's see what you're gonna need to begin with. You're gonna need a Raspberry Pi, Jetson, or any other Linux-based companion computer. I recommend you using Raspberry Pi 0 version 2. Then you need to connect the UART interface of your Raspberry Pi or companion computer to the flight controller, using the Telemetry of the flight controller. Unless you are not sure about the output limitation of your flight controller, I recommend you not using the 5 port of your flight controller for the Raspberry Pi. Next step is to start fresh, and I'm going to assume that we have a Raspberry Pi 0 version 2. Because we are not dealing with any graphical interface, I'm going to select Raspberry Pi OS Lite and the 64-bit version. And I select my SD card. In the settings, you can set your Wi-Fi, so the Raspberry Pi would automatically connect it to the Wi-Fi of your home, so you can do SSH to that. And make sure this SSH is also enabled in the services section. Then just give it a few moments, it downloads and installs the Raspbian OS on your Raspberry Pi. Then if your router settings is by default using the custom domains on your local network, you should be able to ping with your Raspberry Pi, of course after a few moments, with the name of the Raspberry Pi and then .local. Or if this method didn't work, you can use your router settings, go to the router and find the IP of your Raspberry Pi 0. Now we're gonna SSH to our Raspberry Pi. In this case, I set the username to Ali Reza, and then the IP of the Raspberry Pi is 192.168.0.106. And I accept the fingerprint and put the password. And here we are inside our Raspberry Pi 0 command line. Just in case some very rare condition that the NTP or network time protocol is not updated correctly, make sure the date and times are up to date. In this case, for my scenario, it's not updated, so I'm gonna manually update the date and time so I can do the sudo apt update. Then we're gonna do some general commands such as updating your repository with sudo apt update and sudo apt upgrade. And you're gonna need the git as well. If it's not already installed, go ahead and install sudo apt install git and let the git also be installed. When the git is installed, now you can go with the next step in the MAVLinkAnywhere. Just go ahead and copy and paste the commands from the documentation. This command would go ahead and download or clone the GitHub repository of the MAVLinkAnywhere and cd to the direct. Next command is to make the MAVLink router script executable and then run the installation script. That's it. It's gonna go ahead and install the MAVLinkAnywhere and build it. If you are using Raspberry Pi 02, it might take a few minutes, so make sure you wait enough so MAVLink router will be installed. Then run the MAVLink configurator script. It's gonna remind us something that if you are using a Raspberry Pi, you need to, and you're gonna use the UARTs of the Raspberry Pi, you need to disable the shell access to the Raspberry Pi. For that, just type sudo raspi-config, go to the interface, and then disable the access over shell because we're gonna use the serial port. Then we set the serial port enable. When you go to finish, the system needs to be reboot. Once you click on that, your Raspberry Pi would be reboot and you will be disconnected from the SSH. After a few moments, again log into your Raspberry Pi, and now we are good to go to continue with the instructions. We're gonna run the configuration script again. This time we have enabled the UART interface, so we can hit enter to continue. Next step is gonna ask what serial port you're gonna use. We're gonna use the default one, TTY-S0 on Raspberry Pi, and we're gonna use the baud rate of 57600. It might be different if you are using Jetson, so make sure you get the port numbers correctly. Then it's gonna ask for the clients. In this case, I'm gonna add the IP of my MacBook here. Using the ifconfig, I'm gonna get the local IP of my MacBook. It's 192.168.0.103. And you can use any ports that you like, but I recommend you using the port 14550 because it's a default port, and if you enable and if you use this port, QGC or QGroundControl will automatically connect to your drone. Done. As you can see, the MAVLinkAnywhere is done and the MAVLink router is working in the background. Just to confirm, we can copy and paste this command sudo journalctl-u MAVLink router-f, and as you can see, there is no error and MAVLink router is working. To make sure, now all we have to do is to open our QGC or QGroundControl or any other ground control station app you have. As you can see, QGroundControl is connected without any USB interface. If it didn't connect automatically, make sure you go to the COM links and just create a new COM link connection using UDP on port 14550. You can change the parameters here. In this case, we are using Pix4. You can go ahead and search for Telem. As you can see here, we are using the baud rate of default 57600. You can change the baud rate here, or you can enable Telem2 and use Telem2 instead if you also have a radio link RF telemetry on Telem1. You can change the MAVLink interface rates or the modes. For example, if you are using a high latency interface, you can change the MAV0 mode from normal to maybe minimal to just minimize the MAVLink packet size, so you can work with a very low bandwidth operations as well. So since we are using the local network and even 4G, let's keep it on normal, it will work. Okay, let's continue to step 2. Unless you are using an Ethernet base or USB modem, you're gonna use the Raspberry Pi Wi-Fi to connect to your modem. In this case, you might have different kind of Wi-Fi hotspots, or sometimes you're gonna lose connection. So Smart WiFi Manager will help your Raspberry Pi to be always connect to the best Wi-Fi coverage that you have and you have assigned in your network. Using that is very easy, but make sure you follow the instructions here. Unless you are using a very old Raspbian system, you're already using a network manager for the interface of your Raspberry Pi. So just for the sake of being sure, let's install the network manager, but as you can see, it's already working. In some older Raspbian, it was Raspberry Pi used the DHCPD instead of network manager. So in that case, you better disable the DHCPD and use the network manager instead. But be careful, if you disable the DHCPD, then you don't have access to your Wi-Fi. So you should have another options to be connected. As you can see in this case, it says that DHCPD is not available. It means that we are already using network manager and we are good to go. But in any case, if you are using DHCPD, disable it and use the network manager. Then go to your home directory and clone the Smart WiFi Manager repository. Just copy and paste this command. Once it's been cloned, cd to the directory and see the files using the ls. First step is to change the known network configuration file. You can add your SSID and password for different kind of networks that you have. For example, you have 4 or 5 known networks, you put all the names and the password here, then the script knows which network to connect with. Next step is to open the Smart WiFi Manager service and change some of the paths to the script, depends on your system. As you can see here, we need to change 2 items. One of them is exec start, which is the path to where you have cloned your Smart WiFi Manager. And to get that, you can use the command pwd to get your work pin directory. For my case, it was /home/alireza and /smart WiFi Manager. I'm gonna type exact path here, /home/alireza, and again for the working directory, I would type /home/alireza, and that's it. We are good to go. We're gonna use Control X, Y to get out and save. And now all we have to do is to run the install script. So we're gonna type sudo bash install.sh, and it's gonna go ahead and install the shell script and create a daemon service for that. And the next time you boot your Raspberry Pi, everything is automatically connected and the Wi-Fi is being taken care by the Smart Wi-Fi Manager. You can also check the logs here. You can use the system CTL or journal CTL, and as you can see, it's already doing the scan every 10 or 20 seconds. Get the Wi-Fi, see if we can find a known network that is better with signal strength and connect to that. Okay, now let's go to the exciting part, which is sending our MAVLink data over internet. As I told you, there are different sorts of implementations and methods you can use, such as NetBird, WireGuard, Telescale, ZeroTier. But the NetBird is the easiest one right now. Just simply go to the netbird.com, create an account, and just log in. And then you would see a page something like this. You can simply click on this Add Peer to add a new system. Select Linux because we're going to install on Raspberry Pi. Just copy and paste the command. Just like this, we're going to clear the screen and copy and paste. The NetBird and all the dependencies will be automatically installed for you. And that's done. If you are using the official NetBird, all you have to do is to just type NetBird up here. But in this case, I'm using a test self-managed, self-hosted NetBird, so I need to add the NetBird up -- management URL as well. But all you have to do is to just NetBird up. Then it will give you a link. Copy and paste the link to your browser. And using this link, you need to authorize this system, authorize your Raspberry Pi. It's gonna ask you if you allow this node to be added to your network, and you say yes. And here it is. The Raspberry Pi 01 is connected to our network. You should do the same for your laptop, smartphone, and pretty much all the operating system you can connect. You can use your smartphone, get the NetBird application from Play Store or from App Store on your iPhone and install it, and just like we did here, authenticate your system on network. In this case, I've already registered my MacBook on my NetBird network, and you can see this is the IP. This is the IP of my laptop. I'm gonna copy this one, and I can ping between the NetBird over the NetBird network between the Raspberry Pi and my laptop, no matter where they are in the world. Now we need to go back to the MAVLinkAnywhere and change our configuration script. We're going to run the configure MAVLink router shell again as we did in the first step. Hit enter. We didn't change any serial interface, so just click enter. And here, instead of streaming MAVLink data to my local IP, I'm going to copy and paste my MacBook IP on the NetBird account, which starts with 100.93 and so on. I would also add my test smartphone, which is an Android phone here. I would also add the IP of the smartphone here as well. And I will put the port 14550 again for both of them. So the QGC will automatically connect. And that's it. We click enter. And done. Now all you need to do is to open your QGC on your smartphone and on your laptop. And it should be working. Again, if for any reason it didn't automatically connect, go to your application setting to COM links and create a new COM link for the UDP. And on port 14550, You might need to add the remote address of your drone's IP on the NetBird as well if it's needed. And there you have it. You just set up a professional-grade telemetry system that can stream your drone's data anywhere in the world. And here's the exciting part. This setup isn't just for drones. Imagine monitoring your autonomous exploration robot in the mountains while you are on a vacation, or just share temporary access to the telemetry with your team to check live data from your underwater research vessel or any other robots that you have. The possibilities are endless. From giving your client quick access to project data to coordinating multiple robots across different locations. If you found this tutorial helpful, don't forget to hit that like button and subscribe for more content like this. I'm always working on new ways to make our robotic operation more efficient and reliable. I'd love to have you along for the journey. Drop a comment below if you have any question, or if you'd like to see tutorials about other VPN solutions like Telescale or WireGuard, or even traditional methods, or different kind of encryption methods, or improving your security for your drones. I'll read all comments and try to help everyone get their systems up and running. Thanks for watching, and I'll see you in the next video. Happy flying!